All right, y'all, 9.7. Applications of growth and decay. All right, y'all, so we'll look at exponential growth first. So exponential growth, we're looking at investments on continuous compounding or populations. So these formulas will use a P. So this will be the population at any time T. So that's equal to P sub O. This stands for the initial population or amount if you're dealing with money. And then E raised to the K times T. All right, y'all. So remember, this was population or amount if you're doing it with investments at any time T. So if I want to look at 3 years, what the population might be, I can throw in for 5 years, depending on how many years I can find that population. Now that's a P sub O, that's like a subscript, and this means our initial population or amount. Sort of like the principal balance on the last formula, okay? All right, E is Euler's number. K, K is your growth rate or interest rate. And y'all just remember on K, if they give it as a percent, I got to change it to a decimal to throw it into my formula, okay? And y'all, once again, T equals time in years. So this is the general formula for exponential growth. Now, there's other variations of this formula we're going to look at. Like we got one we call the double time. So the double time is the amount of time it takes the population to double or the investment to double. So to find a double time, our formula would be capital T equals ln of 2 divided by K. So capital T stands for double time. All right, so we'll use variations of this. Um, so y'all, let's start with this. Let me let one in real quick. Now there will be an instance later where they want me to find the time, not the double time, but the time. So to find the time later, we'll use this formula. ln of P T divided by your P initial, all divided by K. Okay, so when I'm using this one, they'll give me the ending amount, the initial amount, and my K, okay? Let me also, that's our formulas we're going to play with. So let's play with our first question. So for this example, they're telling me in 2012, the population of a city was 5.31 million. The exponential growth rate was 2.49% per year. So on this one for A, they want me to find the exponential growth function. So basically, you come up with the formula that I would use to find the population at any time t. So remember, we have our P of t. Now, using MATLAB will give you the P of t, and you're just putting in the actual formula. Hey, y'all, so we're using that top formula where I gave you. Can't see it real good here. But we're filling in this formula right here. Our initial amount, E, and then our growth rate times time. So they gave us everything we need. The initial population was 5.31 million. So we'll put 5.31. Now we're going to understand any answer to be in millions on this. And then we had E. So what we need is K now. But remember, they gave me K as a percent. They gave me 2.49%. So do any of y'all want to figure out what that would be in decimal form? And y'all remember the trick on this is to either divide this by 100 or move that decimal left 2 units. So if you move that decimal left 2 units, we're going to have to add a zero in there so that we get a 0.0249. Okay, so you always need your K in decimal form. So y'all, that'll be 0.0249 times T. So if I knew how many years you want me to look at, I can plug in for T, work my formula, and get my new population, okay? So y'all, this is what they wanted in MATLAB for A. So then B, they say, estimate the population in 2018. All righty, y'all. So what we got to do if we're going to estimate the population in 2018, we need to know how much time has passed. So we need to figure out T for this one. So you're looking at 2018 minus, our formula is based on 2012. So this will give us how many years have passed since 2012 to get to 2018. And now if you subtract that, you get 6 years. So we're basically finding P of 6. So we got 5.31 times E to the 0.0249 times 6. Now on these ones, they want me to round it 1 decimal place. Hey, y'all, so I'll just go throw that on my calculator. I had 5.31 I'm going to use second ln to get my e with that exponent there. And then I had 0.0249 times my t, which was 6 years. So if this is exponential growth, then my population has to be bigger than 5.31, because that's what I'm starting with, okay? So y'all, let's hit enter. Now remember, we're rounding it one decimal place, so that'd be like 6 point. Well, I got a 1 there, but after the 1 is a 6. So I'm going to round that 1 up to a 2 and make that 6.2. So that means in 6 years, now MathLab will have the million here. All you're putting in is the 6.2. So that means it's grown almost a million people in 6 years. All right, y'all see. So this one says the population will be 9 million in about blank years after 2012. So they're giving me the ending amount. What they're looking for is how many years have passed. So this is the one where I'm going to use this formula, right? They're giving me the ending amount. I know the beginning amount, and we know K. So we would use this one to find time. Now, double time, I will use this one, okay? But we're just finding the time that passed to get to a new level that they're looking at, okay? So let's use this formula. T equals, and y'all, that's basically this formula solved for the T, okay? So T would equal to ln. P of T was my ending amount. Well, they said that would be 9 million. I know my PO, my initial amount was the 5.31. And y'all, all of that gets divided by K. Well, we know K was 0.0249. So when you have your formulas already solved for different variables, all you got to do is just bring them down, plug in, and move on, okay? You on this one now? Watch how I punch this one in. So I'm going to go to my calculator. So let me clear everything off. And I'll tell you, I'm going to use alpha y equals enter to get my main fraction. Then I'm going to hit ln. And the ln has a fraction. So I'm going to hit alpha y equals and enter to make that look like a fraction. So I had 9 on top, 5.31 on the bottom there. Arrow right and close your parentheses. And then just arrow down to the bottom. And that was 0.0249. So I always punch them in that calculator just like they look on that paper, okay? All right, y'all, let me see on this one. We're going to round it one decimal place again. So let me hit enter. So I get 21.19. So since the 1 has a 9 after it, I'll round that 1 up into a 2 and make that a 21.2. Hey, y'all, so that's the trick on that. Just plug it in like it looks, hit enter, and then round the number of places they want us to, okay? All right, so then we got a part D on this one. So part D, find the doubling time. Now, I know it'll be more than 21.2, and y'all, this will be years after 2012. The doubling time, so 9 million ain't quite double 5.31. So I'm expecting the double time to be a little bit bigger than this, okay? So the doubling time was T equaled ln of 2 over RK. So that'll be ln of 2. K was our 0.0249. And y'all, this one, they also wanted in one decimal place. So I'll tell you what, if you want to know how long it'll take to double any investment, you would use this formula, ln of 2 over your interest rate, okay? Like at 5%, you would put a 0.05 here, and that'll tell you how long it would take to double that investment, okay? All right, y'all, so let's go figure this one out. So alpha y equals enter. On top, I had an ln of 2. Close my parentheses. Then I'll arrow down to the bottom. I had 0.0249. All right, y'all, let's look at it with one decimal place. The 8 has a 3 after it, so I'll keep that at 8 and make that a 27.8. And then, y'all, once again, MathLab will have the years there for you, okay? Alrighty, y'all. So questions on that number one. So that's just a basic formula. Once you come up with the formula, you're going to use it to actually start answering those questions, okay? Hey, I don't see nothing, so let's move on. So y'all, this next one, they want us to complete the following table. All right, so on this table, it'll say population for one column, growth rate K in one column, and then our doubling time, capital T, in one column. So we're going to look at the population of country A and country B. All right, so for country A, they told me the growth rate was 1.9% a year, but they didn't give me country B's growth rate. Now, on doubling time, they didn't give me country A's doubling time, but they gave me country B's doubling time at 43 years. Okay, so they got percent here for that one, and then years here for that one. So what we got to find is the doubling time for country A in years, and then we got to find the growth rate for country B in percent. So we're going back to our formula for double time. So we're looking at this formula. T equals ln of 2 divided by K. Now, if we're looking for K, all we do to find K is flip that with the T. So K is going to equal ln of 2 over the doubling time. So these two formulas will solve for what we got left here, okay? So y'all first, let me find the double time of country A. So that'll be double time is a capital T. Now, if I put a little a down, that means I'm finding the double time of country A, okay? That's going to equal to ln of 2 divided by the K for country A. All right, y'all, so we need this 1.9% turned into a decimal. What would y'all put in here for my K? 0.019, perfect. All right, now look here. Since I'm finding the double time, it looks like they're rounding this to the nearest year. Okay, so the nearest year, the nearest whole number for my doubling time. And then it looks like when I do the growth rate, that'll be just one decimal place. So you want it to sort of mirror what they already got. So y'all, we would go in and punch that on our calculator. So I'm just going to do ln of 2, close parentheses, and then divide 0.019. You can make that look like a fraction if you want to, but I just had one division to do. So I'm just going to do it like that. I'm rounding it to the nearest year. So y'all, we got a 36.4. Since that's that's 4 or less for that decimal place, that means we'll keep this at 36. So it looks like 36 years would be the doubling time for that population to double, okay? So that we would put a 36 right there. Now for country B, I'm looking for the growth rate. So I'm going to find the K for country B. So that's going to be the ln of 2, we said, divided by the double time for country B. Well, country B's double time was 43 years. All right, y'all, so let's go figure out what that'll give us. So I'm going to do the ln of 2 divided by 43 years. And y'all, I'm getting what, a 0.0161. I'll just go out a few decimal places there. But y'all, what you got to think of, this is the decimal form of that answer. I need to turn it back to percent. So to turn this decimal back to percent, I'm going to move the decimal right 2 units. So that's going to give me a 1.61. But remember, I only want to go one decimal place. So that'll be the 6. After the 6 is a 1. So I'm going to keep that a 6. And I'm going to make that a 1.6% now. Now they've already got the percent. So all we do is come in and put our 1.6. So that was a trick on that one. Just come in, use these two formulas to get them two amounts. Okay, y'all, so not bad. Just copy down all these formulas I'm giving you today. And then these aren't too bad. All right, so I used the formula for the population. Now I'm going to use it for an investment. All right, y'all. So they're telling me $10,346 is invested at 5.1% per year, compounded continuously. So since it's compounded continuously, we need to use our formula we came up with in the beginning. So for A, they want us to find the exponential growth function. Now remember, they're going to give us the P of T. We got to fill out our P initial and then our K and our T, okay? So our initial amount is the 10,346. Then we got E. We got to figure out K because we know T will be our variable. So we got to figure out what our K is. So y'all, that was 5.1%. All right, y'all, we need that in decimal form. So convert me over from the percent to a decimal. And I got what, a 0.051? Good job. So that's going to give me 0.051 times T. So this is now the formula we're going to use to find our amounts. So for B, they say, what is the balance? What is the balance after 1, 2, 5, and 10 years? Now, it better be going up every time, right? Because it is an investment. So I'll figure out what it is for T equals 1, T equals 2, T equals 5, and finally, T equals 10. All right, so one way you can plug it in the calculator, put a 1 in for the T, then a 2, then a 5, then a 10. So you can do it individually 4 times and get your amounts. But y'all, I'm going to show you the other way that I would probably do this. And they want me to round it to the nearest cent. So 2 decimal places on these, okay? So I love the calculator. But y'all, I'm going to go to y equals and do this. I'm going to put in my equation, 10,346. Then I'm going to grab second ln to get e with the exponent. And then that was 0.051. Now remember, you can't use t here. You got to use an x for the variable on this. Okay? So there's my formula. Now, I don't even care about the graph. I want to go to the table. So if I hit second graph and go to the table, let me go back up to 1 was where I started. So this would be x equals 1 or t equals 1. Now, you see, if you look at the y1, all of these are rounded to the nearest dollar. But remember, they wanted me to do this to the nearest cents, which is 2 decimal places. So what you do, if you'll highlight the y1 value if you'll highlight the 10,887, and if you'll look on the very bottom on the bar, it says Y1 equals 10,887.33. Well, those are my decimals. So if I'm rounding two decimal places, this one would be 10,887.33. Okay? And then I would do that for, come over here to 2, when X is 2 or T is 2. I highlight 11,457. So it looks like that and rounded up. Because this one is 11,456.98, but the 8 has a 9 after it. So I'll make that a 9. Next was T equals 5. So I would go down to 5. Highlight that 13,351. So I get $13,351.1. So that second one will turn into a 2 because of the 5. So that'll be $13,351.12. And then I had to do 10. So at 10,000 years, I got $17,229. And let's see, the 0 has the 2 after it, so I'll keep that as 0. And that'll be 0.10. So you can get them quick if you do the graphing method. Otherwise, you would have to come in and go 10,346, second ln to get the E, and then you would have 0.051. So we had 1 year first, so you'd have to multiply that by 1 and enter. And you still get to 10,887.33. So y'all, either way, you can do them individually 4 times, or you can go to graph and get all the 4 amounts, okay? Either way on that. So that looks like that on that. So let me find my last question here. And I'll tell you what, this last one is a question that we actually put on our final exam. They can even put a star by this one, because you will see this one on the final. Um, all right, y'all. So this one says, let me see something real quick. See if they changed this one or not. So y'all just hang on a second. I'll be right back. All right, so it's the same. So let me come back to y'all. All right, let me get my screen fixed here. All righty, so on this last one, y'all, here we go. It says there are currently 58 million cars in a certain country. decreasing by 6.1% annually. How many years will it take for this country to have 37 million cars? Then it says round to the nearest year. So y'all, here's one thing on this one. This one is decreasing. So when it's a decreasing, your K will be negative when you put it into the formula. So it's pretty much the same formula. P of T equals your initial amount times E. But since you're decreasing, your K will be negative when you plug it into the formula. Now, they're wanting the time it takes. So we're going to do the version of this where it was solved for the T. The only difference is our K was negative, okay? So y'all, we're going to use this formula. T equals the ln of our final population divided by the initial all over negative K. So your K has to be negative if you're decreasing, okay? So y'all, let's plug it in. We're looking for the time. That's going to be the ln. Our final amount was the 37 million. So we would have 37. Our initial amount was the 58. So when you're decreasing, your bottom will always be bigger than that top. When you were increasing, the top was larger than the bottom, okay? All right, that's over negative K. So that's going to be negative. So y'all, we got to do this again. We got to turn our 6.1% into a decimal. So if we move that decimal twice left, we're going to get what, a 0.061. All right, y'all, so let's go play with that. Like I'll do alpha y equals, make it look like a fraction. So I had an ln, and then I had a fraction in that, so alpha y equals enter. I had 37 on top. Arrow down, I had 58. Arrowed over, close in parentheses. And then down here I had a negative 0.061. So y'all, they're rounding to the nearest year, remember? So when I hit enter, I get 7.36. So I'm going to leave that at a 7. So that would be 7 years for me to go from 58 million cars to 37 million cars. All right, y'all. So questions on that? Hey, y'all, no questions on here, so let me stop my share.